Hello and welcome to the 8th grade math podcast. This is Mr. Morris, and today we'll be graphing a linear equation by finding the x and y intercepts. Before we begin, we need to make an important observation about our x and y intercepts. Let's look at a couple y-intercepts first. This point here, a y-intercept of 4, the coordinates of that point would be 0, 4. Or for this point down here, a y-intercept of -2, the coordinates of that point would be 0, -2. So what we can observe, since the y-intercept is always going to be a point along the y-axis, the x value of those points will always be 0. So the x value of the y-intercept is always 0. And it's exactly the opposite for the x-intercept. If we take this point here, the x-intercept is -5, and the coordinates of that point would be -5, 0. Or this point here, the x-intercept would be 7, and the coordinates of that point would be 7, 0. So we can see that for our x-intercept, where the line would cross the x-axis, the value for y will always be 0. So for our y-intercept, the value of x will always be 0, and for our x-intercept, the value of y will always be 0. Now this is an important concept to understand when we take a look at our problem. Our problem reads, graph 4x minus 6y minus 12 equals 0 by finding the x and y intercepts. If we can find the x and y intercepts, we will have 2 points, and we can draw a line through them for our graph. And we're going to use what we just observed about our x and y intercepts to find their values. Let's start with the y-intercept. Now, since we know that our x value at the y-intercept will always be 0, so to find the y value, we can plug in 0 for x and then solve for y. For instance, in this case, when we plug in 0 for x, we'll get 4 times 0 minus 6y minus 12 equals 0. Which is the same as -6y minus 12 equals 0. Now we want to get our y alone because we're trying to solve for y. So let's get rid of this -12 by adding 12 to both sides, which will give us -6y equals 12. And we're still looking to get our y all alone here, so we need to get rid of this -6, and we do that by dividing by -6. So we'll divide by -6 on this side, and we'll divide by -6 on this side. We'll be left with y over here, and 12 divided by -6 is -2. So we know that our y-intercept is -2. We'll put that down here as y-intercept, and the coordinates of that point are going to be 0, -2. Now let's go over and plot that. 0, -2. And now we can solve for our x-intercept. To find our x-intercept, we know that the y value of our x-intercept is going to be 0. So we can plug in the 0 for y and then solve for x. In this case, we'll get 4x minus 6 times 0 minus 12 equals 0. We'll then get 4x minus 12 equals 0. We want to get the x all alone, so we're going to get rid of this negative 12 by adding 12 to both sides, which will give us 4x equals 12. We divide 4x by 4 and 12 by 4, and we get x equals 3. So our x-intercept is 3, and the coordinates for that will be 3, 0. Now we can go over and plot that point on our graph at 3, 0. So now we have 2 points. We have our y-intercept and our x-intercept. And we can create a line that goes through those 2 points. We're going to check our answer. I've put our equation into our grapher, and if we're correct, the line that pops out should go through the x and y intercepts that we found. And we can see that it does. And that is how we graph a linear equation, by finding the x and y intercepts. And that can be particularly useful when we get an equation in standard form like this. Rather than first rearranging this equation into y equals mx plus b form, we can graph it by finding the x and y intercepts.